Hello guys, I'm a teacher Olimboka Sejuga Masame. Welcome to Olimboka Physics. Okay, we proceed with our relativity between two moving objects. Here we have a moving fluid and the moving object in the fluid. For this case, we will have airplane, boat or a swimmer, and the fluid might be wind or the flowing river. Let us consider the boat and the flowing river. For this case, a flowing river and the boat are moving in the same direction. As usual, we will have two sets of our axes as a frame of reference. The first frame of reference is for moving observer inside the boat, and the second frame of reference is stationary frame of reference as observer from the ground. Observer from the ground is observer along the bank, or from the watching towers as in airplane port. Okay, we have three projected vector here. These vectors from the stationary frame of reference observers shared the same coordinates. We just separate them in order to have a clear understanding and clear sight for what is going on. This observer from the ground will record the velocity of the flowing river, and also will record the resulting velocity of the boat in a flowing river. We know that fluids has influence on a moving object. Either will influence the moving object in such a way that its resulting velocity is bigger than the usual, or will influence the moving object in such a way that its resulting velocity is smaller than the usual. Okay, the observer inside the boat is just a ferryman, or the captain in the ship will record the velocity of a boat with respect to the river as reads from the speedometer or the dashboard. This velocity of the boat with respect to the river is a simultaneous velocity, is a simultaneous motions. At any point, the observer will see himself at a position where the river is flowing. As we are interested with a observer from the ground who records the velocity of this boat as relative to him. As this velocity is what we are interested much, because this is the resulting velocity. Always, also this observer will record the velocity of the flowing fluids, and here is river. This velocity of the river is always ahead from the velocity of the moving boats until this boat reaching the destination. Hence, this observer or from the ground will always see the position of this boat at a point A, while the driver inside the boat will always find himself at a position C. Hence, we will have a three vector. The first vector will be the one where the second vector is drawn on the head of that vector, and the resultant is the one that is drawn from the tail of the first vector to the head of the last vector. As for our arrangement, this arrangement obeys the vector rule for diagrams representations, and by using vector addition rules, we must take this vector 1, we add with the second vector, which is equal to the resultant vector. Okay, according to here below, we velocity of boat relative to river as recorded by this captains or ferryman plus velocity of the river relative to the ground is equal to velocity of boat relative to the ground, and this velocity is what we are interested on. Always this velocity is greater because the velocity of man is added to velocity of the flowing river. This man inside the boat will never notice anything that is going on. He will see himself moving towards his destinations with his moving velocity, that is velocity of boat relative to river. while the observer from the ground, he will see the bigger resultant velocity. Hence, the resultant velocity between the relative velocity between boats and the river will be equal to velocity of boat with respect to the ground minus velocity of the river with respect to the ground. Then we justify this relationship as this velocity is equal to positive by displacement. Our final position and the initial position, then we divide with time. As this velocity is recorded by this moving observer, then our initial positions, which is O-B, is this one. Always this velocity of river is ahead from this. And our final position is position O-A, which is always bigger than our initial position, O-B, which is less. Then we divide it with time. The time is whatever from O to A or O to O dash, as recorded either by observer from the ground or observer who is moving. Then always the answer is positive. Thanks for watching. Please like, share, comment. Don't forget to subscribe for more videos like this one. Thank you.